And yeah, so 3 color images. We know that that was a little tricky, and particularly because we introduced you to, you hadn't really mastered the JS9 image processor yet, and then we introduced you to this Pixlr version. So I'm gonna, we have actually been working this week, Aladdin, the programmer for the website, has been working on modifying JS9 so that you can do these RGB images right there. And so I'm going to show you that process and do the same images in Pixlr, and show you those 2 processes and then upload them into a wiki. So I'm going to go to my images in the activity portal and find a 3 color image. And I want to write down that David wanted to make sure to get some clarification about where youth should post images, and I'll get to that. Okay. Oh, Stephen, welcome. Good to see you here. We are we're taking this webinar to go over some things that people had trouble with. One of the very common issues is with making a true color RGB image. So I'm going to show a new way to do that using JS9. We've just recently, Aladdin is working right now on some tools to make it easy to do in JS9. It's a little, so you're going to have 2 methods for RGB images, one right in JS9 and one using Pixlr. And we have a short tutorial for the Pixlr version, and we'll create one for the JS9 version, but I'm going to show you that now. Stephen, one of the things just before you came on, we asked people to indicate anything they've been having trouble with and would like us to go over. And so that's what's in the chat box now. So if there's something in particular as we go along you wanted help with, be sure to write it down. Okay, so let's see. I'm going to do, oh, it looks like I got an Orion Nebula from last night. I wonder if it came out. Let's see. I'll open the red first. You'll note that Aladdin actually now indicates after the image in your image list what color filter it was taken through, if there was a filter. That can be a little helpful, although, as we said, you can also go to that display fits header to find out which filter. So this is the red filter. One of the things we pointed out to a few people, all of you on right now might not have caught this, that if your image didn't come out, and this Orion Nebula did seem to come out, but you can check what the weather was when the image was taken right in the fits header, right down here where it says weather. It records on a scale of 0 to 100 what the cloud conditions were. And so 100% means 100% clear. And if your image doesn't seem to have anything in it, you might want to check what the weather was. And if it's something like 25 or 0 sometimes, or, you know, that's the reason, because it was pretty cloud covered. It looks like Stephen might have had that situation at some time. All right. So I did seem to get a good Orion Nebula from last night. It's not quite centered. Frank works on the pointing of the telescope, but we'll work with that. Remember, for dim objects, you want to use the log scale to enhance all the dim features. But since it also enhances the dim background sky, once you click on log, you always want to remember to move your cursor around the background sky. Notice its value, its pixel value, right around 298, and set the low brightness limit to that background value. So 298, 298. Oh, somebody's annotating. Yeah, excellent. if you want to draw anything while you're going. So I set it at 298 and I hit my enter button. And now I have a really nice in the red color. If I want to bring this high brightness value down, see if I can enhance this anymore without, I think I like it like that. And remember, I'm going to save this as the red image because this image was taken through the red filter. Okay. Now, if you were going to do your RGB in Pixlr, remember that you would download this image, each one as a separate PNG, and I'm just going to do that now. But I'm going to show you also how to do the RGB right in JS9. So I click Save as PNG. My computer is revving up this somehow. Where do you want to save this? Come on. There we are. I'll save it on my desktop. Red Orion Neb. Okay. Now I'm going to open the green from last night.
Janora can't hear us, and I just don't want her to miss any of this.
Okay. I'm just pausing for a second because Janora has indicated she can't hear us. Janora, I have you logged in twice to the meeting. I'm not sure whether you have two different devices there. I'm going to give you one. I'm going to have Erica actually write the phone number, because one final way, actually you can't hear me, so Erica, if you could type the following phone number into the chat box, maybe I can. Let's copy meeting settings here. Invite. Copy invitation. And I'm going to type it right in. And okay, and if you can indicate she can call that number if she can't hear through her device. Okay, we'll go back to my green Orion Nebula image, which again I'm going to log scale. And it starts to come out there, and then I'm going to set the background to the black limit, the low brightness limit. It's 293. So I'm going to type in 293 into this low brightness limit, and then I can either hit one of these buttons or hit enter. It's now 294, which is fine. And I'm going to see if I want to make that a little brighter, and this was the green. Okay, and I'm going to save that as a PNG. Green Orion Neb. Okay, and then I'm going to open my blue from last night. There it is. Log scale to enhance the dim stuff. Set the background at its level of 290 to make it appear black on the screen. Enter. This is so a lot less light came through the blue filter than through the red filter. I'm going to color this blue. Once again, I'm going to save as a PNG. Blue Orion Neb. Okay. So I have those three separate images downloaded if I want to upload them into Pixlr. But I'm right now going to show you in JS9, we have down at the bottom this RGB mode. Now, this setting down here, RGB mode, only works if you have 3 images loaded into JS9 as we do right now. The blue one's on top, we can't see the others. So yeah, and they have to be colorized red, green, and blue, just as I've done here. So if you click on RGB mode before you've colored the blue one blue, the red one red, and the green one green, you won't see what you're about to see now. I'm going to click on that. Okay, so now I see all 3 images at once, but of course they aren't aligned. And that's before why we had gone to Pixlr, is because JS9 didn't have a tool for aligning. But you see this new little set of arrows, and Aladdin's working on that right now. So let's see how they work. The active image, the last image that was we had was the blue one. So right now the shift is going to work on the blue. So if I go left, you can see those blue dots. I'm click, 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 moving left, click, 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 and you can see the blue move left. So now I'm going to click, click, click to the right. I'm going to try and line up. Actually, I think since it's up a little, I'm going to line everything up with the red, because that's the one down a little. So let me go down, 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 click, 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 click. There, and now to the right to line up my blue dots with my red dots. Very nice. So now I have a nice pink all lined up, and now I want to get that green lined up with the red. So I need to make the green layer active, and you'll remember that I loaded the green layer second. So this one is the green one. Click. And this is the wonkiness that is happening right now. Aladdin will be fixing this. When I went to another image, it forgot it was in RGB mode. So I have to go back and tell it RGB mode. And I click once. Let me try it. There it is. So now I want to shift that green. And which way do I want to shift it? Anyone? See if you're down. Yes, Adrian. Okay, so down. Click, 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 click. And now a little to the left. Click, 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 click. Whoops, too much. There we go. So there's my RGB Orion in JS9. Now I can still adjust these brightness tools a little bit. And now I'm kind of making the green brighter, right? By doing this. So I have a nice RGB. I wanted to show that you can label it right in JS9. So I clicked on text region. I wanted to remind you how to use this. Double click and write in your text. It's a little kludgy. We're hoping to fix this, but nonetheless, RGB Orion Nebula. Okay, and when you type that in, at the bottom of the text entry window, there's this apply button. So I click apply, close this up. There's my label. I want to make it big. Oops. Like that. And I want to put it at a jaunty angle. There we go. And then I'm going to download this as a PNG, because I'm going to show you how to do a wiki using that. So this is RGB JS9, oops, 9, Orion Neb. Okay. So that's how you do RGB in JS9. It's a little bit simpler, we hope, although it has a little few of those wonky things where when you move from image to image, you have to keep telling JS9, oh no, we're in RGB mode, for it to show all three images through each other. I'm going to go to Pixlr. To remind you the way we did it there. Oops. Is the image as good in JS9 as Pixlr? I think that's a really good question, David. I think Pixlr gives you more options to keep editing, like the text that you can add onto it. You can try different colors, and there's although it's also a little more complicated to learn. So I think it's a weighing of whether you want to keep it simple and use just one tool to do it all, or whether you, I think as kids and yourself get more comfortable with making the RGB images, you might find that Pixlr offers some creative possibilities that JS9 doesn't offer. So I think that's the balance. And in fact, I'd say that the professional image scientists like Joe DePasquale, one of our STEM mentors, would say the same thing. He uses a professional version of JS9 to kind of bring out the science data, to bring out the information about the object in space. But then he uses Photoshop, which is very much like this Pixlr editor, to do creative things. All right. To use those three that I had for the Orion Nebula, I'm going to open them from my computer. And remember here's my red. And you remember that you open them as layers. So my next layer, I click on layer, open images layer to get the green. There's the green. And then I open my blue as a new layer, open images layer. And there's my blue. So I now have three layers again on top of each other. You can't see through them. And in Pixlr, the way you see through them is you set this toggle layer setting. You set it to something called screen mode, which basically is as if you were projecting all the images on a screen. But I also think, so now we just set the blue to allow you to see down to the green, and they're lined up pretty well. And now I'm going to set the green mode to screen. And so now we're going to see from the blue down to the green, down to the red. Click. And again, just like in JS9, they weren't aligned. And in the Pixlr application, you use this tool up here, the move tool, to align. And so I click on that. And there's my green image I'm moving right now, because remember, over on the right side of the screen, you can see I'm the green layer, layer 1 is the one that's active. The red layer was layer 0. Okay, I get those lined up. Then I click on the blue layer right here, and I move that. To me, this looks pretty similar to what we got in JS9. But again, there's many more tools for adjusting brightness and contrast in Pixlr. And there's also options for adding text. If I click on this little letter, and again, I'm going to type in, I want some yellow text. And whoops, I want yellow. There we go. Okay. And I type in Orion Nebula. Okay. So again, once I have what I want, I flatten the image so it's all one image, merge the layers, and I save. Again, the default is to save as a PNG, which is nice for uploading into the YouthAstroNet portal. So okay, this is no longer red, it's my RGB Pixlr. All right. So now we're going to go back to our portal and edit the wiki. So you pull, I'm not sure, David, what you're asking. You pull Pixlr off the net, not from the web. Yes, right. You're leaving the portal and opening a new browser window at pixlr.com. It's still a browser-based image processor, but you are doing it in a new window. You can see I have 2 pages here. So now I want to go back. I'm going to erase these annotations here. I like them very much, but let's see, how do I do that? Clear. There we go. All right. So now I'm going to go to the wiki. Actually, let's go back to the educator portal. And I'm going to go to my wiki. I don't have a capstone project yet, so we're going to edit my wiki. Mary's images. And so I did this earlier. That was an earlier Orion Nebula. I did a dumbbell nebula in JS9. I did this one in JS9 using that RGB tool, and I used the text tool. And I even zoomed the image before downloading it. So I want to make a new page to put the 2 images that I just did RGB. And so I'm going to click on Edit in my wiki. Adrian, this is for you. And here's my wiki page. I want to note that if you want to see more, you can actually kind of make it bigger here. All right. You'll see that I have 2 links. I have a link to a new page of Orion images, a link back to the educator images. I want to make a new page in my wiki for JS9 versus Pixlr RGB. Okay, so I'm going to call it, so I put 2 brackets, RGB JS9 versus Pixlr, bracket, bracket. Okay, and now I'm going to save. I look at my page and I now have a link that's waiting to be edited. This is where I'm going to upload my 2 images I just made. Okay, new page title, create page. And the page title is RGB JS9 versus Pixlr. Sorry about that. All right, so this is where, Adrian, we're going to figure out how to resize these images. I'm going to write in, here are 2 RGB images of the Orion Nebula taken on 2/10/16 that I processed during the webinar. Okay, and I want to click on insert an image. And I'm going to find that image, choose the file from my desktop, and I'm going to do the Pixlr one first. Wait, what did I say? What did I call this page? JS9 versus Pixlr? I'll do the JS9 one first. All right. Good. I'm going to upload that. And there it is. And of course, as there it is. It's kind of big. So, Adrian, I can change the size of the image on my web page. I want to mention that micro-observatory images are generally 650 by 500 pixels. So that's if you're uploading a full-size micro-observatory image, it's probably 650 by 500 pixels. Oh, but I guess once I loaded it into JS9, or no, I guess this is a default. So I want to tell it, instead of the usual 600 pixels across, 650, which is a micro-observatory image, let's try about 2/3 of that. So it shrinks it a little bit, but not half as much. So that'd be about 400 pixels across. I'm going to hit my tab button, and it automatically determines the other dimension. So I've now shrunk the image. I go back to general because I realize I forgot to describe. This is Orion Nebula RGB using JS9. Insert. Okay, so I've got that. Now I actually want them right next to each other, but maybe I want a word of text between them. In fact, I'm gonna do this. JS9, right? And I want to make that bold, and I think I can make it a little bigger. Font. So if you click on this here, you get more options. I want to make that big. Oh, let's make it bigger. There we go, JS9. Okay, and then I'm gonna I'm not sure if this is going to work. Okay, now I'm going to try and insert my next image, which is Pixlr. Remember, I choose that file, Pixlr, upload it. There, this one is. This one is where I did that. So this is Orion Nebula RGB using Pixlr. I'm going to change the appearance, and again on the last one I said it was about 400 pixels. I'll make this one about the same size. Okay, and I think I just have to insert it. And there it is. Okay, now I actually want to, whoops, that didn't work. If I hit JS9, I was trying to figure out how to make an arrow going this way saying Pixlr. I haven't quite figured that out yet. So
one of the things that you'll note in Wiki is that when your page resizes, that will change how your images are displayed.
Right. The whole YouthAstroNet portal, Erica points out, is actually mobile responsive. It's responsive to different size screens. So images that might be side by side on a big screen, like I have as I'm projecting this, might end up being one underneath the other on a smaller screen. So, but let's see. I'm gonna. So Adrian, if I wanted to add another line of text, I'd put my cursor at the end of this image and I want text after these two. I'm going to hit return. Return. So when you go back to the, do you have to save each image within the edit box? All right, I'm going to insert a new image and see if I can figure out what you're asking. Let's, okay, so, oh, save. Finder, upload. I choose a, I choose a file. I open it. I upload it. Oops, cancel. I need a new one. I don't know what this image is. It's on my desktop. We'll find out. Oh, okay. That does, so. Oh, this is something fancy I did, but anyway. So Adrian, I have it here in general. I'm going to go to appearance and set it at 400 pixels. Tab. I could just insert it now, although it's going to tell me that I didn't put a label on it. There's no, I don't need to save it anywhere. It's ready to go. Insert, but I do have to insert. I can insert from any of these pages. I would advise not using the advanced tab. If I go back, see if I hit insert now, it's going to give me a warning. Are you sure you want to continue without including an image description? That'll make it not accessible to some people with disabilities. So I'm gonna put that image description in. Two different images added in RGB. Insert, and there it is. So I hope that answered your question, Adrian. I just want to note, I was trying to get creative when I did this. Instead of taking an R and a G of the same object, I did an R of one object and a G of another object. So I ended up having them both appear in the same field. Anyway, now I want to put in some text. This is a crazy image made from two different galaxy images. All right. And now finally, I'm going to make a link back to Mary's images, which gets me back to my first page, and another one back to educator. Is it singular? Educator images.
Scroll to the top, it should say.
Let's see. I'm not there anymore.
Oh.
Well, let's see if it'll automatically link if it's a page that already exists. So that's how I'm making links back to pages that already exist. So let's save that. So here are my two images. JS9, this one's Pixlr, and this is a crazy image. I can go back to my original page of Mary's images, and here's my JS9 versus Pixlr, right? Back to Mary's images. And then I can go back to the main page, which is the main table of contents for all of our wikis. Okay. You can write below the image as well, Adrian. What you have to do there is just hit return, put your cursor after the image, hit return, return, and then you'll be on a new line and you can write text below that image. Okay. Well, that was kind of a long, good. a long way of showing you the two-way of making RGB images. Are there any other questions about that? Hopefully that was helpful. Okay, so I have a couple activities where
Do you want to show them? Show David.
oh,
The activity portal.
Yeah. So David, let's go look at the activity portal for youth, which will be kind of evolving as we sign people up for it. Okay. So I want to make sure you know that. But when we get there, right now, we just created one wiki called Our Best Images. When you sign your students up, we have the Moodle set up so that you will only see the students in your group in here. So you won't have all the other 45 YouthAstroNet educators, students' images, and you have to find your students. You'll just have your students. If you want to make multiple wikis, we can talk about that. I'm not sure how. Right, but if you have ideas for a second kind of wiki, if you want a student capstone wiki versus an Our Best Images, you know, we could make a couple of different wikis within the youth forum.
You can make wikis within specific challenges as well.
Right, and remember that the general. Do we have? Is this a real news forum?
I believe it is a news forum from us. That is why it's up there.
Okay, so we probably want a general discussion forum. Okay, David, thanks for asking this, because this is helping us think this through for you and your students. It may be that you want to put the student images in astrophotography, in which students just keep posting their own, you know, their own astrophotography. But what we will do is create a, so just as you, David, posted your very nice Whirlpool Galaxy image, I must say that looks great. And Stephen, you came up with a really nice one too recently, that was reddish. So students, you could create a specific thread in a discussion forum for your students, depending on what your activity was. So you could just use a forum thread and kids all reply to that and they post their images, or you could use a student wiki. Hopefully that is answering that question.
Yeah, and if you have thoughts, questions,
yeah,
put them in the portal for us so that other people can kind of see what you're thinking about and where you plan on having your students use them.
Great. Yeah. Yeah, so if you have suggestions for a way you'd like, you know, a particular place you'd like them to do that. We are going to, we have things in the background in terms of activities for students to do in these little challenges. So this stuff will be changing very rapidly over the next month. But the basic core of taking and posting images, you certainly have the tools to do right now. Some of these are for kids posting their results of activities, and I'm actually about to show you a couple activities that they could post the results to these places. I want to show you those. I realize, do I have enough lead to move with my earphone? I do. Okay.
Oh, I can hand you mine.
So in the, again, back in the educator portal where we put downloadable curriculum. We have, is it in here? Color images in Pixlr. From pixel to picture, here it is. From pixel to picture, which is an activity about understanding how the telescope creates images. The telescope plus the computer image processing creates images from light that once fell onto a detector at the focal point of that telescope. And so I want to show you that, and we're going to put Erica's. So what you need to do for this is I'm actually going to stop sharing my screen, and I want you to find Erica's.
I think you can pin it for everybody.
Can I pin it? If I do that, is everybody seeing egg cartons? Could you indicate on your big screen? Yeah, if you're not, you want to find the picture of the egg cartons, click on it, and a little box comes up and you want to click on pin video so that you can see that pretty big. Okay, good. All right. So I'm going to come over to my, whoops, we'll try this here. Did you reach those for me? Because I seem not to quite have enough lead. All right. So the detector, hopefully you've got me up there too. Actually, I could do this, I suppose.
Sorry, I'm just going to respond to Jadora. Click on the picture of the egg cartons, and there should be a tab that says pin image or pin screen. Right click. Thank you.
Right click, yeah. All right, so you want the picture of Erica and me in a little box, and the picture of the where my hand is. This should be on your big screen. Okay, all right. So the detector of our telescope and telescopes like it, from the Hubble Space Telescope to any kind of telescope with a digital detector, we think of the digital detector a little bit like an egg carton, where each pixel that's in an image, the source of that signal is particles of light that came through the telescope and those particles of light hit different cells in the detector. And so each cup of the egg carton is like a different cell or well in the digital detector. So the pixels to picture activity first has kids simulate light coming into the telescope. And so in addition to an egg carton, you need some beans or something like that, or beads. And so Erica, would you like to be the celestial object shining into our telescope?
I love being a bright shining star.
Oh no, I have a tilted telescope. Here we go.
2 stars.
All right. So now I actually have another version of this. So here is a previously exposed detector. There we are. We're looking at that. And you can see that this detector is 6 by 6 pixels, not 650 by 500 like Micro Observatory, but 6 by 6. And you can see that there's a lot of light that got focused onto this pixel. No light at all in this whole line of pixels, right? A lot of light fell in this one, and these two next to each other. All right. So basically there's electronics in the telescope that send information in numbers, and those are the numbers that are behind when you click on the pixel value tool in JS9, and it shows you all those numbers from 0 to 4095. It's giving you the signal that came into each of those pixels. And then you have to tell a computer how to represent that information and visualize it. And that's what image processing is visualizing the information from the light that came to the telescope. So you remember that there was a lot of light through these 2 pixels. And here's the first representation Erica made, those 2 pixels. There was a whole line of pixels that had nothing in them. And this representation, it looks to me like, in fact, the number of slashes you actually have 1 to 1. So there's 2 slashes in this pixel, 2 here, I don't know, 11, 12 or 13 here. And so here she's represented the raw data with these different slashes in this 6x6 array. So the activity asks kids to think about if they're communicating the information about how much light came into the telescope, how would they do it? This is one way. Here's another way, and where dark blue represents a lot of light and the light blue represents a little. And what kids find out right away is that when you are, the activity asks kids to create a representation and then trade representations with other students and try to recreate what was in the original egg carton. So they have to recreate the raw data from their visualization. And if you don't send the code that white means there were no light fell in, 1 to 5 is light green, 6 to 10 is dark green, 11 or plus is dark blue. If you don't send the code, it's very difficult to recreate how many photons fell into that detector. So this particular color palette doesn't give a lot of resolution because you only have 4 different brightness values. So Erica did another one where you have 6 different brightness values, and now you can see more differences around the screen here. And the same thing is true of those different color palettes in JS9. Some of them, you know, like the shadow one, you really only see 5 or 6 different color brightness values, whereas the gray and the rainbow really give you 255 different values. So this activity is one to help you understand how the signal that was originally in a telescope falling on a detector ends up as a digital image. And the pixel to picture activity walks you through that. If I go back, I'm going to just share my screen briefly here. So if I go back to JS9 here, and I open up that Orion Nebula here, right? And I don't know. So there it is. Remember, if you do like this, this shadow, right? There's all this color palette only uses like 10 different color values from red to green, whereas the I don't know, the heat has a lot more definition with multiple levels of orange, or in this blend rainbow, there's a lot more different color values. So each one of these is a different way, a different code that kids would send from one to another to recreate the image. Any questions about that activity? So to teach background or noise, yes, David, exactly right. So the fact that as I click around my image, I'm gonna bring up that pixel table. So like you see, as I click around the background, which is the night sky, it's not 0, it's 297 all the time. So the night sky itself has light in it, and that's exactly right, David. The background in the image. So all the pixel, all the cups start with a few beans in them because there's background light. Very good. Okay. All right, the last activity that we want to show you is kind of the engineering robotic aspect of the fact that your students are going to be controlling real machines through their YouthAstroNet portal, and we want to open up that black box of how the telescope that they're controlling works. And I think we mentioned earlier, I'm gonna go back to, let's see, I need to go back to right. Once again, you want to click on Erica's video and right click and click on pin video so that you see this contraption here, and I'm gonna explain that contraption. So we have some design engineering activities, which are also going to be in your curriculum section shortly. Yeah. So and they are around design challenges of creating subsystems of the telescope using these little bits, electronic parts, which we will loan you. These are expensive. We know they're expensive, but we have 4 sets which we can ship to you for a week or 2 at a time. We haven't quite figured out how the scheduling is going to work in terms of whether you get to keep them for 2 weeks or 1 week. But at any rate, you can sign up, and Erica's getting all the sign up forms ready. They'll be on the portal, so you sign up for a week. We'll ship you a workshop set that comes in this very cool little suitcase here. You're looking at my video now, which has a workshop set of parts in it. And if you're looking at my video, you can see there's lots of pieces and parts. So I'll have you put that aside. Well, we're back to Erica's video here. I realize I need just a little bit more length on that. Okay, so I'll let you monitor from. Yep. Yeah, I'm kind of closing it here just so I can see my. All right, I need to pin in here. There we go. All right. So these little bits are multiple little pieces that come apart. And the nice thing about them is there's no soldering involved. They use magnets to put together, and they're actually color coded with the power supply is always blue, connectors are always orange, inputs, which means things that make other things happen, are always colored pink. So this is a button input. This is a little toggle switch input. This is a, oops, this is a slider input. Inputs are always pink. And outputs, which are the things that happen, are always green. And so this little output here, green, goes to a little motor that is attached to this piece of cardboard. And so this subsystem right here, power supply, a button, and a little motor, so the button activates the motor, is one solution to the design challenge. How would you create a shutter that opens for a certain amount of time and then closes? And that's what's happening when the kids set the exposure time in the telescope. I'm going to turn on my power here, which, by the way, is just a 9-volt battery. And right here is my shutter. I'm going to push my button. Whoops, here we go. There we go. Open for 10 seconds. Closed. Open. Closed. Another design challenge, and we've got them all together in one part here, would be, here's a light sensor underneath this shutter that actually is kind of like a 1-pixel detector. There's a single little light sensor, and that's the input. So depending on how much light that sensor detects, the output is, there's 2 outputs. There's this little bar graph here, which was too bright for my webcam, so I had to put a little filter over it. And there's a little readout. Can anybody see what that readout is reading right now? I don't know. Can you see that in the, are they typing that in?
Not yet.
Does anybody see what the digital readout is reading?
28.
Yeah, right. So 28 is right now the background level of light that our light sensor is sensing from the room, but I'm going to open up, the sensor is under my shutter. I'm going to open my shutter and expose the light sensor and see what the light value that's background 28 moves to. Here we go. 1, 2, 3, open. Anybody see what that is?
54.
54, yeah, close. And it's back to, I actually didn't close all the way, it's back to a little higher background level. And you notice this bar graph also goes up and down. So that's 2 ways, we've got 2 solutions to the design challenge. How do you measure the brightness of a light source? Because a telescope has to do that. The design challenge is, you need to build a circuit that's going to somehow measure a signal of how bright a light source is. And that requires a light detector and some kind of measurer. Another part of the circuit is over here. There's a motor and a slider that activates the motor. And the design challenge here is, how do you aim your sensor, your telescope detector, at a particular place around the room? And if you watch, this whole structure is holding the sensor. I'll move. You can see as I move the slider, it moves the angle of the whole structure to point in different directions. And this is the other direction of motion. If I had a motor, I could also aim it around the room that way. So in each kit, there's enough pieces and parts so that all your kids in groups can solve these design challenges in different ways. The ways we solve them in this contraption might be different from the way your kids solve them, but it helps them think about the subsystems of the telescope. Are there any questions about that? You can. The other thing, you could also, we have a design challenge. Whoa.
Sorry. Sorry about that, guys.
I'll share my screen again, but so oh, a question about JS9. Yes, Stephen. I can either unmute you or you can just hear. I'll tell you what. Where are you here? I can unmute you and does.
Hello, everybody. I'm such a slow typer.
That's all right. People can hear you now.
Okay. All right. So my question is, how do in the zoom function in JS9, how do we do the panning? How do we allow the panning to take in the image? Panning and the magnifier and those things.
Great. Yeah, good question. I have it on screen now. Can you see an image on screen?
Yes.
Okay, so I'm going to zoom in. And it's kind of way too far up there, right? I want this in the middle of the screen. So I use the panner tool.
Mm-hmm.
It's a tool. It's one of three, right?
Mm-hmm.
And if I go like this, if I just drag it,
Okay.
like that, right?
Okay.
So I just drag the panner to center the thing I want centered in the main window.
Okay.
And
then to secure that position, how do we do that?
Once you close this, that's the.
Then it's already okay.
Yeah.
Okay, cool.
And so if you save this image as a PNG,
Mm-hmm.
it'll save just what's in the window here.
This is the one. Okay.
Yeah.
Excellent.
If
Thank
I
you.
zoom in further, and that's not quite where I want it. I go back, use that panner.
Okay.
Okay, whoops. There we go. And then that's where it is.
Excellent. Cool.
Yeah, great.
Thank you.
And Adrian, to answer your question, there'll be basic instructions about the pieces and parts of the Little Bits kit that tell you about what the parts are, and then there's the design challenges. There's also, actually, I should mention that while we have specific design challenges that are around understanding the microobservatory robotic telescopes, these pieces and parts can be used for lots of things. The idea is for kids to learn these engineering skills of imagining a problem they need to solve, testing ideas, and collecting data about how well those ideas solve the problem, and then redesigning their solution. So those are engineering skills that they can use not only to make a shutter that opens and closes, but to make something that is of interest to them. So they can, there is a website where they actually sell these things, but they're very expensive. But it has lots of great project ideas. So, for the week that you have that kit, if you have time to go beyond the YouthAstroNet challenges, there's many other things kids can do. And those project ideas are at littlebits.com. But we'll have a basic manual that does go with the kit. How much do they cost? Well, that's why we got them for you. Each of those little bits, each piece and part can be
Actually, price I gave is cheaper.
$5 to $10. Yeah. So, and we're, so Yeah, so we're giving you a kit that's worth many hundreds of dollars. so there'll be labels in the kit about how many pieces were in it, and they're all in these little boxes and they're color coded. So all you have to do is kind of look at the inventory list that says how many should be in each box, and that's how you keep track of them. Other questions? Well, so this is the last formal webinar for this little February online training session. That doesn't mean it's the last webinar. We hope to kind of offer webinar opportunities monthly that are optional to come ask questions, learn more, to keep in touch. And of course, this training session is the start of a conversation, not the end of one. We are going to be on the educator portal. Whenever you have questions, we'll be monitoring that and be able to answer them. As we mentioned earlier, the post-workshop survey will be on by the end of day tomorrow, and Erica's going to send some information out to everyone about how to plan for completing your workshop work, and we will be creating a certificate that each of you will get, and a badge that says you've been through the YouthAstroNet training, you're YouthAstroNet certified, and then shortly there will be all kinds of a whole new section on the educator portal for how to sign a group of kids up and get them accounts on the portal for your implementation. All right. David, goodbye to you. And sorry we went a little bit over, everyone. I'm going to stop the recording.